A run-behind greenhouse effect, also known as a reverse greenhouse effect and a refrigerator greenhouse effect, is a process that results in decreasing greenhouse gases respired into an atmosphere of a celestial body over time, and thus increasing greenhouse gases deposited into that celestial's interior over time, the net effect of which is decreasing atmospheric temperature over time. Let's break down this definition. So a run-behind greenhouse effect, or a reverse greenhouse effect, or refrigerator greenhouse effect starts with a process that results in decreasing greenhouse gases respired into an atmosphere of a celestial body. So we just have a few amount of gases coming out each day from the ground into the atmosphere of a celestial body. Let's look at the second part. It says, thus increasing greenhouse gases deposited into that celestial's interior over time. So over time, we have a little bit of greenhouse gases coming out of the ground, but we have more greenhouse gases going into the ground. The net effect of this is decreasing atmospheric temperature over time. And this involves the greenhouse effect. So when sunlight comes in, and it hits a planet's atmosphere, passes through the atmosphere, and comes to the ground of that celestial object absorbs all of that energy and re-radiates in the infrared. Over time, much of this greenhouse gas that was in the atmosphere is going into the ground. Its few is being released into the atmosphere. The net effect is that this infrared radiation can continue to escape from the planet, thereby cooling the planet over time. Each day that passes on this planet or exoplanet, the temperature decreases over time. Hence, we have a reverse greenhouse effect, otherwise known as a refrigerator greenhouse effect or a run-behind greenhouse effect. The run behind part is because the greenhouse effect is putting fewer gases into the atmosphere. Hence, we have a running behind of putting greenhouse gases into an atmosphere of this celestial object.